Okay, we're going to go over some word problems using the techniques we've talked about for solving quadratic equations. Before we get into that, we're going to do a couple of review problems that deal with simplifying some expressions here. So on number 1, if you're given 3m squared times the quantity 4m minus 5, you want to distribute your 3m squared to both the 4m and the 5. So multiplying 3m squared times 4m, we're going to have 12m cubed, and then 3m squared times negative 5 is going to give us a negative 15m squared. Okay. Moving on to number 2, do the same thing here. We're going to distribute the x. So x times x is going to give us an x squared, and x times negative 8 is going to give us negative 8x. Number 3, we're going to distribute the 4x. So 4x times x is going to give us 4x squared, and 4x times 3 is going to give us a positive 12x. For number 4, we're multiplying a binomial times a binomial. So first we're going to take the 6x and distribute it to the 2x and the 3. So that's going to give us 12x squared. 6x times positive 3 is going to give us a positive 18x. Next, we're going to come back and distribute the positive 4. So positive 4 times 2x is a positive 8x. And a positive 4 times a positive 3 is going to give us positive 12. Next thing we need to check for would be any like terms that could be combined together. So we have a like term here with the 18x and here with the positive 8x. So I can simplify this final answer to 12x squared plus 26x plus 12. Moving on to number 5 here, same idea. We have a binomial times a binomial. So we're going to start with the 3x and distribute it to the 4x and the 2. That's going to give us 12x squared plus 6x. We're going to come back and distribute the negative 8. So negative 8 times a positive 4x is going to be negative 32x. Negative 8 times positive 2 is a negative 16. I have a like term here with the positive 6x and here with the negative 32x. So this would simplify to 12x squared minus 26x minus 16. And the last one here, number 6, binomial times binomial again. We're going to distribute the 5a to both the 2a and the minus 1. That's going to give us 10a squared. 5a times negative 1 is negative 5a. Come back to the first binomial, and we're going to distribute this negative 4. So negative 4 times 2a would be negative 8a, and a negative 4 times a negative 1 would be positive 4. Our like terms are the negative 5a and the negative 8a. So I'd have 10a squared, negative 13a, and a positive 4. All the word problems we're going to be looking at today are going to deal with the area of a rectangle. And you talked about the area formulas last year in your 7th grade math class. Area of a rectangle is given by length times width. L stands for length, W stands for width. So in this first problem here, we want to write an equation that represents the area of each rectangle. And then we're going to solve it to find what the value of x would be. So on number 1 here, we're going to set up our formula. It's A equals length times width. Now they tell me that my area is 24 square centimeters. So I'm going to take the capital A out and replace it with 24. If I look at the figure they've drawn, I know the length of my rectangle is the x plus 2. So I'm going to plug that in for L. And then the width of the rectangle is x. So I'm going to multiply that by x. And this is really the same thing as saying x times x plus 2 in parentheses. So to simplify something like this, we do what we just did above. We're going to distribute the x. So the equation would become 24 equals x squared plus 2x. Now, on most of these, I would try to factor to solve them. And in order to factor this, I would need to get this 24 over to the other side. So to get rid of the 24 on this side so that the equation's equal to 0, we would need to subtract it from each side. So that's going to leave me with x squared plus 2x minus 24 equals 0. I'm going to bring this up here so I have a little bit more room to finish this. I'm going to have x squared plus 2x minus 24 equals 0. So we want to try factoring. There is no GCF here. There's nothing that x squared, 2x, and negative 24 have in common. So I know that when I factor it, I need to start each factor with an x to get the x squared. Now I need two magic numbers that multiply to give me negative 24 and add to give me a positive 2. So I would need to use a positive 6 here and a negative 4. Right? Positive 6 times negative 4 gives us the negative 24. And then if I add 6 and negative 4, I get the positive 2 in the middle. Once we've factored it, then you're going to set each factor equal to 0 and solve it. So we have x plus 6 equals 0 and x minus 4 equals 0. To solve the first equation, we're going to subtract 6 on each side. So I have x equals negative 6. In the second equation, we're going to have to add 4 to each side. So x would be equal to positive 4. Now, since x represents the width of a rectangle, we can automatically rule out any negative answers, right? Because it doesn't make any sense to say that something has a negative measurement. So x would be equal to 4 would be the solution that we're looking for. On the second problem, we're looking for the value of x in this rectangle when we're told that the rectangle has an area of 18 square yards. And so we're going to set up our formula again. Area equals length times width. Since we're told the area is 18, I can replace the capital A with 18. For the length of the rectangle, that would be x minus 1. And for the width, we would have x plus 2. So on the right side of this equation, I have a binomial times a binomial. So to simplify that, I would multiply the x first by distributing it to the x and the positive 2. That would give me x squared plus 2x. And then we would come back along and distribute the negative 1. So negative 1 times x and negative 1 times positive 2. That would give me a negative 1x and a negative 2. Come back through and combine our like terms just like we did on the problems above. You get 18 equals x squared plus x minus 2. And we would try to factor this first, solve by factoring. So to do that, I would need to subtract the 18 on both sides because we want our equation equal to 0. So we're going to have x squared plus x minus 20 equals 0. Okay, so let's try factoring this now. Again, we look at the equation to see if there's a GCF. X squared, x, and negative 20 do not have a GCF. So we know the first part of each factor would need to be an x and an x to multiply to give us the x squared. We're looking for two magic numbers that multiply to give us negative 20, but add up to give us a positive 1. It's understood there's a 1 here in front of the x. So that means our magic numbers would have to be a positive 5 and a negative 4. Okay. And then we're going to set each of these factors equal to 0. X plus 5 equals 0, and then x minus 4 equals 0. Okay. For the first one, we would subtract 5 on each side, and then we end up with x equals negative 5. For the next one, we would add 4 on each side, and x is equal to positive 4. So we look back at the original drawing. If we were to assume that x was negative 5 and plug it in for x minus 1, that would give us a negative 6 for the total length of this rectangle, which is not a possibility. So we can ignore this answer, and our answer would have to be 4 for the x value. A couple of other reminders, since some of the word problems today are going to involve the phrases more than or less than. Anytime that you see the phrase a number in a problem, they're referring to the variable x. When they use the word more, we're talking about obviously addition. When we're talking about less, that would be subtraction. And then anytime the more or the less is followed up with the word then, that's the signal that they want us to reverse the order that we write the variable and the numbers in. And this makes a little bit more sense when we look at some of these examples down here. When it says 4 less than a number, obviously the word 4 means the number 4. Less means subtraction. A number would be the variable x. This then part tells me that I want to switch the order. So instead of the 4 coming first and the x coming second, we're going to swap places. The x will come first, and then the 4 will come last. And this would be how we would write the expression 4 less than a number. It'd be x minus 4. On number 2, same thing. They start off with the number 8. We have the word more, so we know that we're talking about the operation addition. A number would be x, but since it says then, that signals that they want us to switch the order. We want to write the x first, then the operation addition, and then the 8. So 8 more than a number would actually be written as x plus 8. And the last one here, 7 more than a number. Talking about the number 7. Again, more means the operation addition. A number is the variable x. Then means that we're going to switch the order. So 7 more than a number would be written as x plus 7. Okay. That's important to remember the order that you write them in, because that can change the sign of your answers and throw the entire answer off if you're not careful. Okay, on the back side of your notes, here they're not going to give us the picture. They're going to ask us to come up with the picture and then use the phrases to set up the length and the width of the picture. Okay. So in this first one, we're just going to draw a generic rectangle. They tell us the length of the rectangle is 2 less than the width. Okay, so remember we have the number 2. Less is the operation subtraction. The width is the unknown number. Okay, so we could say W or you could say X, whichever one. And then the word then means that we're going to swap the order. Okay. So the length, which would be this piece right here of the rectangle on the bottom, would actually be W minus 2. Because 2 less than the width, we would switch the order that we write the 2 and the W in. So W minus 2. And then this side, the width, would actually also have to be W, since we still don't know what the width is. And they tell us the area of this rectangle is 80 square feet. So using our area formula for a rectangle, we know it's length times width. That would give us 80 plugged in for the area. The length is W minus 2. And then the width is just W. We can distribute the W. That would give us 80 equals W squared minus 2W. And again, I would always try factoring first, since that's usually the quickest and easiest way to get the answers. Before I can use factoring, though, I need to get this 80 on the other side by subtracting it. So I would subtract 80 from both sides of the equation. I'm going to bring this up here since we've run out of room. This is going to give us W squared minus 2W minus 80 equals 0. We're looking for two factors that would multiply to give us negative 80, but then add to give us negative 2. So the two factors that we would want to use here would be a W, let's see, minus 10, and then a positive 8. Because negative 10 times positive 8 is negative 80, and then when I add negative 10 and the positive 8, I get the negative 2. And we're going to set each of these equal to 0. So W minus 10 equals 0. And then W plus 8 is equal to 0. Add 10 to each side. And we get W equals 10. And then here we would want to subtract 8. And then W would equal negative 8. And remember what we said earlier, that if we're talking about the actual measurement of the side of a rectangle, we can't utilize negative measures or negative numbers. So we would rule this one out, which would mean that our answer would be 10. And since it was square feet, this would be 10 feet. So the width would be 10 feet. Okay, moving on to number 2. The length of a rectangle garden is 6 more than the width. The area of the garden is 40 square meters. Let's find the width. We're going to start off the same way. Set up a rectangle. The length, so that's the bottom piece of the rectangle, is 6 more than the width. So we have a 6. More means the operation addition. The width could be W or X, whichever letter you want to use. I'm going to use W since it matches with the word width. And then the word then tells me that I need to change the order that I write my expression in. So I would reverse it and it would become W plus 6 for the length. And then W is standing in for my width. And we're told the area of the garden, the inside, is 40 square meters. Do the exact same thing we did in number 1. Area is equal to length times width. I can replace the area with 40. My length is W plus 6, and the width is W. I need to distribute the W over here on the right side. So it's going to give me 40 equals W squared plus 6W. Okay. Again, I think it's usually a good idea to try factoring first because that's usually your quickest option to get the answer. So to do that, we're going to subtract 40 from each side. So that way, we're going to get the equation W squared plus 6W minus 40 equals 0. So I'm going to rewrite this up here since I've run out of room. W squared plus 6W minus 40 equals 0. There's no GCF here, so let's try to come up with the magic numbers that would work. So I'm looking for two numbers that multiply to give me a negative 40, but are going to add to give me that positive 6 in the middle. So if we try positive 10 and a negative 4, 10 times negative 4 is negative 40. 10 added to negative 4 gives us a positive 6 in the middle. And then now we're going to set each of these factors equal to 0 and solve for W. Okay, so in the first equation, W plus 10 equals 0. We would need to subtract 10 on each side. That gives you W equals negative 10. And in the second equation, we would need to add 4 to each side, which would give us W equals positive 4. Again, we can't have a negative measurement for the side of a rectangle, so we can cross this one out. And that means that W would need to be equal to 4. And since it was the area was 40 square meters, that means the width would have to be 4 meters. So this would be the width of this rectangle. Okay, moving on to number 3. The area of a rectangular rug is 63 square centimeters. The length of one side is x plus 6. The width is x plus 4. Find the dimensions of the rug. So this problem is a little bit different in that they didn't give us the verbal phrase for the sides. They just tell you what the algebraic expression is for the length and for the width. Another thing that's a little bit different is that they want us to find both dimensions, not just the width. They want us to find what the length is as well. So if we set up our generic rectangle here, and we have x plus 6 for the length and x plus 4 for the width, we know the inside area is 63 square centimeters, since that's what they told us right here. So we know the area is equal to length times width. Replace your area, or capital A, with 63. Replace your length with x plus 6. And replace your width with x plus 4. We have a binomial times a binomial here on the right. So we're going to start with the x and distribute it. We're going to multiply this first x and times the positive 4. So that's going to give us x squared plus 4x. And then now we're going to distribute the 6. We're going to multiply 6 times x and 6 times positive 4. So that's going to give us 6x plus 24. So let's clean up the right side of the equation first. We can combine the 4x and the 6x to give us 10x. So we have x squared plus 10x plus 24. And then now if we're going to try factoring, then we would want to subtract 63 from each side so that we get the equation equal to 0. So we're going to have x squared plus 10x, and then we're going to end up with a negative 39 equals 0. And since we're running out of room again, I'm going to move this up to the next column. X squared plus 10x minus 39 equals 0. No GCF here between the three terms, so let's go ahead and try to factor it. Come up with the magic numbers that would work. We know that we're going to start with an x and an x to get the x squared. I need two numbers that multiply to give me this negative 39, but then are going to add up to give me the positive 10 in the middle. So I could use a positive 13 and a negative 3. 13 times negative 3 is negative 39. And if I add positive 13 and negative 3, I get the positive 10 in the middle. Set each factor equal to 0. So x plus 13 would be equal to 0. And x minus 3 would be equal to 0. To get the x by itself, we're going to subtract 13. That gives us x equals negative 13. To get the x here by itself, we're going to add 3. So we end up with x equals positive 3. Okay. If we look at our original measurements here, one of them is an x plus 6. If I were to replace the x with negative 13 and add 6 to it, we would get negative 7. And we can't have negative measurements for the side of a geometric figure, so we can exclude that answer. And then I would just double check and make sure that your second possibility still makes sense. So if we were to replace the x here and the x plus 6 with a 3, we would get 3 plus 6, which is equal to 9. And then here on the side that's the width where you have x plus 4, you would have 3 plus 4, which would give you 7. So your dimensions for this rectangle would be 9 centimeters by 7 centimeters. And then just to double check, 9 times 7 obviously gives us 63, so it makes sense in terms of what they gave us in the original problem. Number 4, we're actually going to wait and come back to these problems when we get into the next section on graphing. So you're not going to have to do problems like this. We're going to skip this one and come back to it in the next unit. So these notes should hopefully help you get started on the word problems assignment for today, as well as go back and do some of the word problems that are on your study guide for the test that you have on Monday. I'll make another video to help you guys out with the study guide, working through all the problems so that you're prepared for the test on Monday. If you need any extra help outside of classroom, I'd be happy to help you before school or after school in room 304.